Hi guys, I'm Swati from the Department of AI and DS. We are going to learn about half and full subtractor. Half subtractor. The half subtractor is constructed using XOR and AND gate. The half subtractor has two input and two outputs. The outputs are difference and borrow. The difference can be applied using XOR gate and borrow in output. Can be implemented using an AND gate and an inverter. Input and output variables. The input variables are a comma b and the output variables are s is equal to sum and c is equal to carry. And this is the truth table and the circuit diagram. When you give the inputs as 0 and 0, the output is 0 and the difference is 0. And when you give the input as 0 and 1, the borrow is 1 and the difference is 1. And when you give 1 and 0, the borrow is 0 and the difference is 1. And when you give the input as 1 and 1, the borrow is 0 and the difference is 0. And this is the K map. Here is the list of components. To input AND gate, the IC specification is 7405. And to input XOR gate, the IC specification number is 7486. And one input NOT gate, the IC is 7404. And two input OR gate, the IC specification is 7432. So now we are going to see about full subtractor. Full subtractor is a combination of XOR and OR NOT gates. In a full subtractor, the logic circuit should have 3 inputs and 2 outputs. The two half subtractor put together gives a full subtractor. The first half subtractor will be C and A, B. The output will be difference output of full subtractor. The expression AB assembles the borrow output of the half subtractor and the second term is the inverted difference output of the first XOR. Moving to the second slide. Input and output variables. The input variables are A comma B and the output variables are borrow and difference. And here is a circuit diagram. Full subtractor using two half subtractor, and this is the truth table, and this is the K map. Here is a list of components. Two input AND gate gives the specification number as 7408 and two input XOR gate the specification number is 7486 and one input NOT gate the specification number is 7404. This is half subtractor. We are taking 3 switches as input. And we are taking 2 XOR gate. The first one is AND gate and the second one is NOT gate. And now we are taking 2 outputs. And now we are labeling the switches as the first one is A and the second one is B. And you're labeling the gate as XOR. And the top one is NOT and the bottom one is AND gate. And you're labeling the output as borrow and difference. Let us start connecting. Now connect the switch A to XOR gate and NOT gate, and switch B to XOR gate. And now we are connecting the NOT gate to AND gate, and switch B to the AND gate. And now we will be connecting XOR gate to the output and AND gate to the borrow output. Turning on switch B, we get two outputs, difference in borrow, and turning on switch A, we get only one output, that is different. And turning on both, we didn't get any output. Moving to the next one, full subtractor. We are taking 3 switches and one XOR gate, one AND gate and NOT gate, we are taking another NOT gate and AND gate, and the another one is XOR gate. Finally, we are taking the OR gate. And now we are taking the output so now we will label them. We are taking the first switch as A and the second switch as B and the third switch as borrow. And now we are labeling the gates. The first one is XOR gate and the other one is NOT gate. And the third one is AND gate. Moving to the next side, the first one is NOT gate and the second one is AND gate. This is XOR gate and this is OR gate. So we will try connecting them. And I'm giving the output as sum and the difference as borrow. So now we will connect them. connect switch A, XOR gate and NOT gate, and connect switch B to AND gate and NOR gate, and connect the borrow switch to the first one, NOR gate, and again connect the borrow switch to AND gate. And now we are connecting the NOT gate to AND gate and NOR gate to NOT gate and XOR gate to XOR gate. And now we will connecting NOT gate to AND gate and AND gate to OR gate. AND gate to OR gate. Now I am connecting the OR gate to borrow switch and XOR gate to the output difference. I am turning on the switch A, I am getting one output as difference. When I am turning on the switch B, I am getting two output, difference and borrow. And when I am turning on switch A and B, I am not getting any output. And when I am turning on all the three switches, I am getting two outputs in total. That is difference and borrow.